Okay, today we're going to look at two different types of chemical reactions. The first one we're going to look at is called a synthesis reaction. Synthesis reactions are also called combination reactions, and what happens is you're going to bring together a couple of simple things. In your case, it's going to be two different elements are going to come together. Okay, so I'm representing those with A and B, and you're going to make a more complicated substance, which means we're going to make a compound. Okay, so two simple substances, which will be elements, are going to combine to form a complicated substance, which will be a compound. Usually, synthesis reactions are going to release heat. So synthesis reactions are called exothermic reactions. Okay, and let's take a look at the next page. I'm going to do a couple of examples on the next page, which are really similar to what you're going to see on the worksheet that you're going to have for homework. Okay? So let's look at the top paragraph here. They brought together phosphorus and oxygen. Okay, those are two different elements. And they made a more complicated substance, which is a compound. Now, in this example, what they did was they wrote plus energy on the product side. So what that means is heat energy is going to be released when this reaction takes place, and that's what makes this an exothermic reaction. Now, you will not write plus energy or plus heat on the product side. It is just there to emphasize the fact that you should know that synthesis reactions are usually exothermic. Okay? So, what we're going to be doing is we're going to be combining elements like barium and chlorine to make a compound. And you're going to be predicting the compound that you're going to make. The way that you do this is write it out in words. So you would write barium plus chlorine. Why does chlorine have a little subscript 2 on it? What does that tell me about chlorine? Chlorine is what?
It has a charge.
You highlighted it on the right-hand side in an upside-down L.
Oh, it's a diatomic.
It's a diatomic element, so that's why it has that little tiny 2 on it, okay? In order to predict the products, you need to write it out in words first and then bring the words together to make your compound. So when you bring barium and chlorine together, you're going to make a compound that's called barium chloride. Do not look at the subscripts that are on the symbols on the reactant side to predict what the subscripts will be on the product side. It might work sometimes, but it will also be wrong a lot of the time. So the way that you predict what this chemical formula is you will look at your periodic table. Barium is a +2, chloride is a -1. You would need 2 of these chlorides to make your neutral compound, right? Because the charges need to add up to 0. So this would end up being BaCl2. Okay, then you would balance it from there. Does this make sense what I'm saying to you? So write it out in words first. Then look at the charges to predict the chemical formula of the product. Okay? Do not look back at the subscripts on the reactants, okay? Okay, let me do one more with you. So, in this other example, they've given us tin and oxygen. On the worksheet, you won't have the chemical formula of the product. You'll just have an arrow, and then you're supposed to write the product yourself. So you would write tin plus oxygen, bless you, and then you would bring those two together to write the name of the product. Now, tin is a transition metal. Don't the transition metals have varying charges? Okay, so what I want you to do when you have a transition metal and you're predicting the compound, you will always assume that transition metals have a +2 charge. So that's why I wrote the Roman numeral there after the tin. Okay, so this would be tin, Roman numeral 2, oxide. That would be the name of the compound that I'll make. Okay, then we will look at the charges to predict the product. Okay, tin is Sn. The Roman numeral 2 means it has a +2 charge. What's the charge on oxygen typically? On the periodic table? -2. If I have a +2 and a -2, don't those already add up to 0? Okay, so that means my chemical formula would be SNO, and that's what we have. Okay, then you would go back and balance it, and then you're done. Okay, the states of matter are only included if you know what they are, and you really don't know what they are on that worksheet. Does that make sense? So you don't need to include them on that worksheet. Okay? All right, do you want to try some on that worksheet before I go on and do the opposite direction? So numbers 1 through 7. Why don't you guys try the first 2? Write them out in words, and then predict the name of the product, and then look at the charges and go from there, okay? Okay, let's take a look at decomposition reactions. And then that's all we're going to do today. So let's come down here. Decomposition reactions are the reverse of synthesis reactions. So what I'm going to do is I'm going to take something that's complicated, like some compound, and I'm going to break it down into 2 or more simpler substances. For you, it will be 2 elements. So I'm taking compound AB, and I'm breaking it down into elements A and B. Since this is the opposite of a synthesis reaction, that means that they will be absorbing energy. Okay, so they need a continuous source of energy to go, typically, and we use that energy to break the bonds in the compound, and then this would be called an endothermic reaction because it absorbs a bunch of energy to break the bonds, more energy than it does to release when the bonds form. And so we're going to take a look at going in the opposite direction. So let me give you an example. If I had given you compound Al2O3 and I asked you to predict the elements that would form, which 2 elements do you think it would form? Aluminum and oxygen. Are either one of those elements diatomic? No. Oxygen is diatomic, right? So you would have to put a little subscript 2 on it. So you've got aluminum oxide decomposing into aluminum and oxygen. You can do this the same way that we did the synthesis reactions. You would just write it in the reverse order. So aluminum oxide is going to decompose into aluminum plus oxygen. And then at this point, we would balance it. I would recommend balancing the oxygens first because you've got 3 oxygens on the left and 2 on the right. 3 and 2 go into 6. So I would put a 2 here. 2 times 3 would give you 6 oxygen on the left. And then I would put a 3 here. 3 times 2 is 6 oxygen. And then you have 4 aluminum. So I would put a 4 here. Does this make sense? Okay. So this is how you do decomposition reactions. And that's all we're going to do today. So the last half of your worksheet is decomposition. I'm going to walk around and help you. Okay.